Hello everyone, how are you all? Hope you all are doing well in your life. Let us now discuss some concepts on machine. Okay? Students, let us now discuss about kinds of levers. Okay? So as you can see, there are three kinds of levers: class 1 lever, class 2 levers and class 3 levers. In these three levers, the positioning of fulcrum, load and effort, they differ from each other. So let us now discuss about these three levers in detail. So we'll start with class 1 lever. Okay? Students, as you can see, this is a class 1 lever. So in class 1 lever, the fulcrum, it lies between the effort and the load. Okay? This is effort, this is load, and this is fulcrum. Okay? So here FA is the effort arm and FB is the load arm. Students, you just need to remember that fulcrum does not need to lie at the midpoint of the lever. It can lie anywhere between effort and load. And effort and load, they actually are in the same direction. Here you can see that they both are in the downward direction. Students, we can take many examples of class 1 lever from our day-to-day life. For example, see, this is a pair of scissors, isn't it? Here you can see that the arms of the scissor, they are moving around this fixed point. This is your fulcrum. This is your effort, where I am actually applying the force, my effort. And here, when I want to cut this paper, this is my load. So, where does the fulcrum lie? The fulcrum is lying between the effort and the load. So, that is why this is a class 1 lever. Okay. Another example that we see from our childhood is the seesaw. Students, here you can see how beautifully the seesaw is moving. The seesaw is moving up and down, but it is fixed at the center. So the center is nothing but the fulcrum. The load and the effort, they are at a certain distance from the fulcrum. See, in class 1 lever, when we put effort on one side, the lever tends to move in the other direction. That means if we put effort in the downward direction, the load moves in the upward direction and the lever moves about the fulcrum. Okay? Hope you understand. Students, as you can see over here, this is a class 1 lever and FA is the effort arm and FB is the load arm. But what you can clearly observe that over here FA is greater than FB. That means the effort arm is greater than the load arm. So these type of class 1 levers, they work as force multipliers. Force multiplier. So what happens over here? The effort arm is greater and the load is closer to the fulcrum. That means the load arm is smaller. So we put less effort and the effort is multiplied and that is used to do the work, or that work is done on the load. That is why it is called force multiplier. For example, if we take this plier, when we use such pliers, suppose we use this plier to take a nail that is dipped into a wall out. Okay. So what you can see that this is the fulcrum which is fixed and the two arms are moving about the fulcrum. So this is the effort that we put in. Here we put the effort and here the nail is to be inserted. That means that is the load. So load is acting over here, effort is over here. So fulcrum to effort is effort arm. You can clearly see that effort arm is greater than the load arm. So what we do over here, we put less amount of effort and that effort is multiplied. That means the force we apply on this handle is multiplied and we can easily take out the nail out of the wall. Okay. So that is why such class 1 levers where the effort arm is greater than the load arm, they work as force multiplier. Okay? Students, here in this type of class 1 levers where effort arm is less than the load arm, that means here FA is less than FB. So the displacement of effort is less than that of load. So DE is less than DL. So in this case, the lever is used to gain speed. For example, if you take a pair of scissors, okay, what is happening over here? See, this is the fulcrum and here we put our effort and this is the load. So you can clearly see that the distance of fulcrum from load, that is the load arm, is greater than that of fulcrum to effort, that is effort arm. So what we actually use, we put effort over here, and if you put any paper or cloth over here, that is the load, you can cut the paper or cloth very easily. That means the reaction will be very fast. We can do the work very fast. So we gain speed. Okay. So in class 1 lever, where FA, that is the effort arm, is less than the load arm, there we gain speed of work. So in such cases, the mechanical advantage is also less than 1 and velocity ratio is also less than 1. Students, in case of class 2 levers, the load is always in between fulcrum and the effort. Okay, so as you can see, the load and the effort are on the same side of the fulcrum. Okay, and here the effort arm is FA and the load arm is FB. And as the load always stays in between effort and fulcrum, that is why the effort arm is always greater than the load arm. Okay, and as the effort arm is always greater than the load arm, mechanical advantage of class 2 lever is always greater than 1. And since in idle machine, mechanical advantage is equal to the velocity ratio, so velocity ratio of class 2 lever is also greater than 1. Okay, let us now take the example of nut crusher, which is a class 2 lever, and just try to understand how it works. Okay. Students, as you can see in this nut crusher, the fulcrum stays at a fixed point. We put effort at the handles. So the distance of fulcrum and the effort is the effort arm. The point at which we put the nut is the load. So the distance of load from the fulcrum is less than that of the handle from the fulcrum. That is why the effort arm is greater than the load arm. So when we put effort, as the mechanical advantage is greater than 1, we can crush the nut very easily. Okay. So as in this case, mechanical advantage is always greater than 1, we can say that very less effort is required to overcome the high resistive force. Students, let us now discuss about class 3 levers. As you can see over here, in a class 3 lever, the fulcrum and the load, they lie at 2 points of the lever and the effort lies in between load and fulcrum. So it is clearly understood that the effort arm is always smaller than the load arm because effort lies between load and fulcrum. And another thing is that the effort and the load, they always are on the same side. See, they are at the same side. In this case, what will happen? The mechanical advantage is always less than 1 and the velocity ratio is also less than 1. So these are not force multipliers, but we can generate greater speed because in this case, smaller displacement of the effort arm gives us greater displacement of the load arm. So we can gain speed. Okay, students, we use a knife at home. This is the example of a class 3 lever. See, for a smaller displacement of the effort arm. So where does the fulcrum lie then? Where is the load and where is the effort? Which is the effort arm? Which is the load arm? We need to understand. We have already discussed that the fulcrum and the load, they lie at the end point. See what is happening over here. This is the fixed point, isn't it? This is the fixed point and actually it is moving like this. So your fulcrum is at this end. Okay. And effort, where you put effort? We are not putting effort over here, we are putting effort over here. So this is our effort and where is the load? Whatever we are going to cut is the load. So the load is at this end. So you can clearly see that the effort arm is smaller than the load arm. The smaller displacement of effort arm gives us the larger displacement of the load arm. That is why it can increase the speed. Whenever we try to cut vegetables or fruits or anything using a knife, we can have a greater speed, isn't it? Students, let us now discuss some examples of levers found in human body. Okay? In human body, we can find the examples of all the three classes of levers. The muscles exert force by contraction, and this is nothing but effort. So in class 1 lever, as you can see, we can take the example of nodding of head. What is happening over here? The spine acts as the fulcrum F. Load L is at its front part, while effort E is at its rear part. Thus, this is an example of class 1 lever. For class 2 levers, we can take the example of raising the weight of the body on toes. What is happening over here? The fulcrum F is at the toes at one end. The load L, which is nothing but the weight of the body, is in the middle, and effort E by muscles is at the other end. Thus, this is an example of class 2 lever. For class 3 levers, we can take the example of raising a load by forearm. What happens over here? The elbow joint acts as fulcrum F at one end, biceps exerts the effort E in the middle, and load L on the palm is at the other end. Thus, this is an example of class 3 lever. Okay? Hope you understand. Students, hope you have enjoyed the class today. We have discussed some concepts on machine. You need to go through your book and revise everything properly, so that all the concepts that we have discussed today will be there in your mind forever. Okay? So for a better future, for a better concept clearance, just keep revising, keep practicing, and most importantly, keep smiling.